Hey all, today I'm going to be doing an easy on Leetcode 929 unique email addresses. So when I first started doing Leetcode or learning Leetcode like 3 or 4 years ago, this one always confused me, but it's because it's one of those problems where the explanation is needlessly complicated. But basically, they give you a list of emails, and when normalized, you have to count the unique emails that you have. So, what do we mean by normalization? Well, there's a set of rules. For example, if you add a plus sign, everything after the first plus sign in the local part of the email is ignored. And then every time there's a period, it's just ignored. So basically, the best way to explain this is to take the test case and then go and apply the rules manually. So we have like these rules here, right? And I'll try to space this out a little better. So we have these emails. So first we go to this one here. And let's apply these normalization steps. So the first one, which is the more important one, is if you add a plus in the local name. And first you have to separate it by local and domain. So that's always just separated by an at sign because there can only be one at sign, right? So you have the local part and you have the domain. Domain never changes because that's just the domain, unless there's any domain rules. I don't think that there is. Yeah, no, it's the exact literal domain. So domain, that's it. We split that off and that's nothing. Then next, we have the local part of the domain and we apply the plus rule, which means everything after the plus is ignored. So just delete everything after the plus. And then you have test.email. Then we apply the other rule. If you add periods between some characters in the local name, mail sent there will be forwarded to the same address without dots, which basically means you can remove the dots. So this one essentially gets normalized to this test email at leetcode.com. And that's actually the first one. So then next you go to this one, and I'll be a little bit faster. I just kind of wanted to explain this. It might be confusing to people. Is you separate local, domain, you chop everything off the plus like that, and then you remove the periods. And then this one gets normalized to that one. And you can see already, it looks like it's the same as the top. Like that. Yep, it is. And then we get the last one. What happens? Separate local, domain, chop everything outside of the plus sign, and then put these back together. And then this is number 2. And the answer for this, which is the real answer, if you look in the results over here, the expected answer is 2. That is because these are the same and this one is different, like that. And the reason why it's different is because the domain's actually different. See, it's like a completely different website. So these are 2 different emails, but the local parts are the same, but it doesn't matter because they're from different domains. So anyways, that algorithm that we just laid out, we will write manually here. So we'll do it that way because I think it's the most readable way to do it. So first, to count the unique emails, let's use a hash set and just get the size at the end, and that'll maintain the uniqueness for us. So for that, let's just create like a set of strings, right? And let's go unique emails equals new hash set, like that. And then at the end, let's just get this all set up. We know that we're just going to return the size at the end. Next, we're going to go for each email in all emails, we're going to normalize it. And for this, let's go ahead and get all of our preparation out of the way. So let's get the local name, and let's get the domain name. And then for this, let's actually go like this. Let's go string parts is equal to email.split. Let's go split by the @ sign, right? And this is going to be the first part of that, and this is going to be the second part of that. And let's get that out of the way. Now, from here, and then we'll recraft the email at the end as well. So the domain is just there. The domain is going to stay. But then the local part, we have to apply these rules. So first, let's apply the plus. So let's go let's go local name is equal to local name and let's split it by the plus sign and chop everything off. So if we split it by the plus sign, then it'll just be the first part of it. And I'm pretty sure in Java, if you split by a character that doesn't exist in the string, it will just give you the whole string anyway. So this should work. So that will apply our first rule. This is the this takes care of the plus rule right here. Now we want to take care of the period rule. So for that, I'm just going to replace everything. So this will be everything. We'll just replace the dots by nothingness, like that. I think that'll work. Can we do replace? Yeah, we can. Okay, so then once we have that, we have the local name. Now let's reconstruct it back together. So we will add this, and actually let's go string email. So the final email, so normalized email, is equal to, and we will just go like local name plus @ plus domain name. And let's add it back into the unique emails like that. And we'll run this. Let's see, what did I do wrong? Dangling meta character plus near index. Oh, that's because split is actually expecting regex, or it will read it as regex if there's a regex token in it. So I think we have to do plus, like literally like this. And that's an invalid escape sequence, so I think we'll need 2 backslashes like that. Yeah, it looks like that's good. I'm going to submit that. And that's good. And the reason why we needed to do this is because plus is actually a regex token. So it won't interpret it as the character plus. It'll interpret it as the regex plus. So, and you can't do one single backslash because then it'll be looking at like, the other kind of characters. So then you have to do the double backslash for the literal plus. And this looks pretty good. Yeah, let's go through the time complexity here, or attempt to. It might be difficult. I mean, we know it's already ON minimum because we have to go through every email. For this, we're doing some splits and some replaces, but these splits and replaces are ultimately bound to the max word length, the individual word length. So we can, if we want to be strict, we can go n times m, where n is emails and m is max length of an email. Something like that, if you want to be strict. And then space, we already know is ON, right? A worst case, and that's the case that you store every email. So yeah, hope this made a little bit of sense, and I tried to make it as clean as possible. Yeah, hope you enjoyed. Thank you.